in this video tutorial, I'm going to review how to solve a system of equations by graphing. The most important piece to remember here is we always want to get all of our equations in the system to y equals. The reason being is when we get there, our graphing calculators can handle it and actually graph it for us. So in my first example here, I have a y plus 71 equals negative 3x squared minus 30x. So we aren't into y equals yet, so we want to move that 71 over. So subtract 71, subtract 71. So my first equation is now y equals negative 3x squared minus 30x minus 71. I also need to do some rearranging in my second equation. So I need to move that 3x to the other side. So subtract 3x, subtract 3x. So my second equation becomes y equals negative 17 minus 3x. Once you have all the equations in your system to y equals, you can take your graphing calculator, and we're going to let the graphing calculator do a lot of the work for us. So first thing we need to do is we need to plug these in. Best way to do that is your graphic calculator has this button top left, it says y equals. You hit that. Now for the sake of this video, I already plugged in our two equations, so you don't have to wait for me to type those in. Once you have them both typed in and you're ready to graph, hit the graph button. Now what we're looking for with a system of equations, and we're solving by graphing, is we're looking for where they intersect. So this parabola opening down, that's equation 1, and this line coming through, that's equation 2. So looking at it, it looks like there's two intersections. There's one here and one down there. So I'm going to need to calculate what are the coordinates of each of those intersections. So I'm going to start by calculating this first intersection. The way we're going to do that is at the top, all these buttons have to do with the graphing function of the calculator. I want to calculate that intersection. So if you look at the top, it says here calc. So what I'm going to do is I'm going to do second calc. And it lists a whole bunch of options there. Again, I'm trying to find the intersection, which is option 5. And the calculator is going to go through a series of questions so it knows exactly what intersection you're talking about. The first question it asks is, what is the first curve, is essentially what it's asking. So what is your first graph that you want to use? Well, we want to use the y equals negative 3x squared minus 30x minus 71. So it's asking, hey, do you want to use this, which is listed up here that I'm pointing at? Do you want to use this as your first curve? We do, so I'm going to hit enter. And it's already going to kind of figure out, hey, do you want to use the other one, the y2, which is my second equation? Do you want to use that as your second curve, it's asking. We do, so I'm going to hit enter again. The third question it asks is it wants you to guess where this intersection is happening. Now what you're going to do is you're going to move, as you can see the crosshair showing up, using the arrow keys on your calculator. Move the crosshair as close as possible to where that intersection is happening. Once you have the intersection kind of roughly pinned out, hit enter, and you'll see your calculator will calculate the intersection. So this first intersection, the coordinates are x equals negative 6, y equals 1. So one of my answers is x equals negative 6, y equals 1. But as you remember, there was two intersections here. There was another one down here. So I'm going to repeat that exact same process to calculate that second intersection. So to see that again, we're going to do second calc. We want option 5 for intersect. We're still using y equals negative 3x minus 30x minus 71, so hit enter. We're still using the negative 3x minus 17, which is our second. Hit enter. And then it wants us to guess where's the intersection. Right now it's flashing at the one I already calculated. So I'm going to hit the arrow to the right, and that crosshair is going to slide down to the other intersection. Right around there is good enough. Hit enter, and it tells me the other intersection is at x equals negative 3, y equals negative 8. So this system here had two solutions, both of them calculated using a calculator. I'm going to do one more quick example. So I have negative y equals negative 1/3 x minus 2, and that's my other system. This one is already into y equals, so that's perfect. We can type that in just like that. This first one, we have this negative with the y. We do not want that. So what I'm going to do is I'm going to multiply by negative 1. If I multiply the left side by negative 1, I got to multiply the entire right side by negative 1. The reason that works for us is a negative times a negative gives us a positive y. And I'm going to take that negative 1 and distribute through that entire parentheses. So a negative 1 times a negative 1/3 is positive 1/3 x. Negative 1 times negative 2 is positive 2. So I'll use this as our first equation, and I fixed our second one so it's into y equals. So we are ready to go back to our graphing calculator and enter these two equations. So I'm going to go to y equals, have my old ones in there, so I'm going to hit clear and clear both of those out. Do negative 3x squared minus 5x minus 4. That's going to be my first one. Arrow down to my second one. If I want to do 1/3, I'm going to do 1 divided by 3x plus 2. So I have both of these entered, so I'm ready to graph them. So my first equation is this parabola here. My second equation is this line here. And again, we're looking for where do they intersect. So quickly looking at this, these two equations do not intersect. It will never touch it. So what that means is we have no solution on my second example. Again, that was solving a system of equations by graphing.